Section 3.3 Implicit Differentiation and Related Rates. We have objectives to use the method of implicit differentiation to solve for a derivative and to solve for a real-life rates. The implicit differentiation is the process or the method that we use to find the derivative where the function is not in the explicit form like y equals f of x. What is another form that we don't say it's in the explicit or we call the implicit function form. So implicit function example, it could be like x squared plus y squared plus x times y equals 1. So x and y all over the place. They're not like very obvious like y equals x squared. That's what we've been dealing with for this kind of explicit function. So this situation is called explicit, but this one is called implicit. And your goal is to find the derivative. And the rules that we use to find the derivative during the process, it could be the general power rule, could be the general power rule, or the chain rule, or the product rule, or other rules that we have to use as based on the term that we have within that implicit expression. Okay, so let's see the example. Like the first one, we're gonna find dy by dx of y to the third power. And this one, we can see that we consider y as a function of x. Okay, to find dy by dx, we consider y as one whole quantity. And we're going to use the general power rule. For the general power rule, if you recall, it's in a form like y is in terms of the function g raised to the power n, and then when you find y prime or dy by dx, you're gonna have to bring the n down and then the gx raised to the power n minus 1 and multiply by g prime. So that's the pattern of the general power rule. And similar way, now we do not have the obvious form of the g function um, or y is not provided in the obvious way or in the explicit way. So when we find the derivative with respect to x of y to the third, it's going to be following the general power rule where the n is 3. Okay, it's going to be 3. And then pretend like y is the same as the g function. If we don't know what y going to be. So going to be multiplied by the quantity y to the power 3 minus 1 and then multiply by y prime. So what we have is 3y to the second and then multiply by y prime. And this is the derivative of the expression y to the third power. Or you can write it as d by dx of y to the third equals 3 times y to the second times dy by dx, which is a notation, another form of the notation of the derivative of the y with respect to x. So either this form or this form would be the final answer.